Okay, hello everybody. As you can tell, or you will be able to tell in a few minutes, I have a cold. So I'm recording this from home so I don't infect any of you and hopefully keep you up to date with where we are in our courses. And let's begin. These are the handouts that I have provided for you in Blackboard and at my office that you picked up a copy while you were, if you were on campus. And basically, I'm going to start with these problems and we're going to just work our way through module 8.2 and 8.1 and 8.2, I believe, is the ones we're starting on. Let me grab that other page because I'm starting you way ahead of where I wanted to be. Here we go. So 8.1, 8.2. Now, I've already kind of gone through this once, and I'm going to write the problems down here on a piece of paper for you. If you want to, you can do the same thing. It kind of gives us more space to work. What this basically says in 8.1, what we're looking for, and the directions tell you, is you're looking to find the restrictions on the variables. How do you do that? Well, you'll set the denominator to 0. We know that that's a forbidden thing. No denominators of 0. So if the denominator in a fraction is 0, then you know you have something that is not allowed, and that would be a restriction. So for this first one, we would set the first denominator, which is 9 minus x, we would set that equal to 0. And then we would solve for x. And what you do is you subtract 9 from both sides. You end up with negative x is equal to negative 9. And then, of course, you divide both by -1, and you say x is equal to 9. But basically, we're looking for restrictions. Look at this. If we put in 9 for x, it would be 9 minus 9, which would be 0. We know x can never be equal to 9. That's the restriction on the variable. So what is our restriction? Well, x can be anything, but x can never be equal to 9, can it? Let's take another one. The second one has as the denominator, I'll write it here, 2x plus 9 is equal to 0. So all we have to do is solve for x, and we'll say 2x is equal to a negative 9, and then divide both sides by 2. Well, this is going to be a negative 9 halves, isn't it? So what can x never be? And I'll write it like this. X can never be 9. X can never be negative 9 halves. Otherwise, we would have an invalid fraction, wouldn't we? We would have 0 as a denominator. The next one's a little more complicated. The denominator for the thing is a trinomial. X cubed plus 2x squared minus 8x is equal to 0. And we really basically are going to have to factor this thing. I see a GCF. Don't forget, that's always your first step. Factor out the GCF. And I factored out my GCF of x. Next, I'm really going to have to factor this trinomial. Let's see if I can factor it. It looks like a simple trinomial. It would have one of each sign, plus and minus. I would factor the x squared, and then I'm looking for factors of negative 8. If you want to draw your diagram, you can, that are going to subtract to give me a positive 2. And that would definitely be, I would think, 4 and 2, right? Well, I need a positive 2, so I need a positive 4 and a negative 2 to get me that positive answer. So this one's going to be 4, this is going to be 2. I would FOIL this to check it. And it works. X times x is x squared. 4 times negative 2 is negative 8. Inside would give me 4x. Outside would give me a negative 2x. When I combine those, I get a positive 2x. So I have 3 factors. Here's 1, here's 2, and here's 3. And I'll set each of those equal to 0 and solve them. And the first one is, of course, already solved. This one is x is equal to negative 4, and this one is x is equal to positive 2. When I go back to my original equation and I say, what is invalid? Well, if x is going to be a 0, what would happen is that it would turn this denominator into 0. If x was a negative 4, it would also turn the denominator into 0. If x was a positive 2, it would turn the denominator into 0. So those are the 3 ones that x can never be 0, it can never be negative 4, and it can never be a positive 2. We've already determined that by setting our denominator equal to 0 and looked for the restrictions on the variable. Now number 4 is, we're going to skip it because it's the same problem that I gave you earlier. I duplicated it for some reason. Let's go over to page 12 here, and let's check out what we're going to do with Module 8, Homework 2. First, we're going to solve equations that have rational expressions. In other words, equations with fractions. What you keep in mind is your first step with solving one of these equations, and keep in mind these are equations, they have an equal. We are going to multiply each of the fractions, each of the terms, by a least common denominator. And when we do that, we basically multiplied the same sides, each side of the equation, by the same number, which we're allowed to do, right? Without changing its value, we can multiply both sides by something, we could add the same to both sides, we could subtract. We're going to multiply each term, which is like multiplying two terms and distributing, right? So we're going to multiply each side of the equation by the same LCD, and that will turn everything into whole numbers, and it'll be a lot easier to solve. Now, a lot of times, these are much easier to work if you write them on with some space between them. And so that's kind of what I'm going to do over here. I'm going to take this problem, and I'm going to give it some space. I'm going to say problem number 1 would look like 6 over y plus 1 over 11 equals 3 over y. And then I look for an LCD. Well, I have 3 denominators, y, 11, and y. So when I look for a common, least common, I know I have to include what's in all of them. It's going to be 11y. So I'll multiply each term in the equation times 11y. Well, this is being multiplied a fraction, so I'll write it over 1. This is being multiplied times a fraction. I'll write it over 1, and same thing here. It just makes it easier to see what you're doing. And then you have 2 fractions multiplied. You can cross-reduce anything in the numerator with anything in the denominator. In other words, these y's are the same as y divided by y, which is 1, y over y. Over here, these 11s do the same thing, 11 over 11, and here we have y over y. So I've gotten rid of everything that's going to cross-reduce. Everything that I've crossed out turns into the number 1. I don't really see a reason to write that for every one of them. You understand, all of these 1s in the denominators make these whole numbers. So I have 6 times 11 is 66. And over here I have 1 times y, which is just y. And now I have 3 times 11, or 33. So I have 66 plus y is equal to 33. Well, I want to solve for y, so I'm going to subtract 66 from both sides. And I'll come up with y is equal to a negative 33. Now, I've got to check it. I really have to check it to make sure that when I put it back in the original, I'm not causing an invalid condition. I'm not causing a negative to be, a 0 to be in my denominator, right? Or anything that doesn't work, a no solution type of thing. So I've got 6 over, and I'll just solve this one. I've got 6 over y, which was a negative 33, plus 1 over 11 is equal to, and that would be 3 over a y, which was a negative 33. Let's just see what this does for us. I've got 6 over 33 plus 1 over 11. I kind of like these. These are like, I'll just take these negatives and put them out in front of my fractions instead of being in the denominator, okay? Whoops, you can't see me, can you? Okay, let's fix that. So when I take them and put them in front of the fraction, hang on just a second. Okay, I think I've got my camera working now. So I take them and put them in front of the fraction. It's just the entire term becomes a negative. But I really need these all to be in 33rds so I can compare them. This one needs converting. How do we do it? Well, we multiply both the numerator and the denominator by the same number. So this is a negative 6 over 33 plus 3 over 33 equals to a negative 3 over 33. Well, negative 6 plus 3 is a negative 3, isn't it? Same denominator now. And that looks like it checks out. Because my next problem is really going to be 2 fractions equal to each other. And they have the same denominator, so to clear those fractions, all I have to do is multiply them by that same denominator, and I'll have whole numbers. Let's write it down over here so we can try it. This is problem number 2. And I have x plus 3. I'm going to put it in parentheses so we'll understand that it doesn't factor anymore. We're just going to treat it as a single item, is equal to 2 over x plus 1. Now what happens when I multiply everything by my least common denominator of x plus 1? Well, multiply this times x plus 1. Since it's being multiplied times a fraction, I'll write it as a fraction over the denominator of 1. And I can see how these will cross-reduce. So I have x plus 3 is equal to 2. Well, I'll subtract 3 from both sides, and I'll get x is equal to negative 1, right? All right, so what happens when I put negative 1 back in my original problem? Well, I would end up, look at this one, I would end up with negative 1 plus 3 over negative 1 plus 1. And at that point, you can go, nope, this will not work. That would cause 0 as a denominator. Negative 1 will not work as a solution, so I have no solution to this problem. It caused an invalid condition. Let's look at example number 3 now. We have two different denominators, x plus 2, x minus 2. Well, you know to get an LCD, you're going to have to combine them. So I'm going to write it down. I have 6 over x plus 2. I'm going to put it in parentheses so I treat it as a single item. Give it some space because I know what I got to do now. Over 5 is equal to 5 over x minus 2. I know my LCD here. It's equal to x plus 2 times x minus 2. So I'll multiply that times each of these. Make it a fraction. Put it over 1. Now, start reducing. Well, the x plus 2's will reduce, and over here the x minus 2's will reduce. So I really have 6 times x minus 2 is equal to 5 times x plus 2. Let's distribute. That's 6x minus 12. That's equal to 5x plus 10. Let's see what happens. We're going to subtract 5x from both sides, aren't we, to get this started? I end up with x minus 12 is equal to, those cancel, positive 10. I'll add 12 to both sides. And I end up with x is equal to 22. So, to check this, all I would do is plug in x, 22 for x, back in the original problem. It would be 6 over 22 plus 2 is equal to 5 over 22 minus 2. Well, this is 6 over 24 is equal to 5 over 20. And I can reduce both of those fractions. This becomes 1/4, doesn't it? Both divide by 6. Both of these divide by 5. I also have 1/4. And it does check. It doesn't cause an invalid condition. Anywhere, I'm good with that solution. Let's check the next one. Next problem is number 4, right? Number 4 is 4 over x minus 2 is equal to 16 over x squared minus 4. And it looks like we got a little work to find the least common denominator in this one. So let's just write it out here. This one is 4 over x minus 2. I'm putting that in parentheses because I can't do anything with it as it is. But I'll put some space. Is equal to 16 over x squared minus 4. Now, I can't find an LCD until I have factored this binomial, but fortunately, this is a difference of two squares. So it factors into one of each sign, square root of the first term, square root of the second term. Now I can cross that out because I just factored it and replaced it with the two binomials. Now I can see my LCD. It has to include both of these, and that one, fortunately, that one is inside them. So LCD is equal to x plus 2 times x minus 2. So when I multiply times my LCD, over 1, it takes me longer to write this out than it does to explain it. I can start reducing. Well, here the x minus 2's will reduce. And over here, x plus 2 and x minus 2 will reduce. So I just have a numerator over here of 1, but this one I've got to have 4 times x plus 2, don't I? Is equal to, well, everything became 1, so it's just 16 times 1, right? Let's distribute. We have 4x plus 8 is equal to 16. Subtract 8 from both sides. We have 4x is equal to 8. Now we divide both sides by 4, and x is equal to 2, isn't it? However, is that going to work? Already I'm thinking this could be a problem, because the original problem said 4 over x minus 2. Well, that's just one part of it, but if I put 4 over 2 minus 2, I know I can't have that. So it causes an invalid condition when I plug in 2 for x and I don't have a solution for this one, okay? It would be invalid. All right, let's look at number 5. Two fractions, this time equal to 0. We're going to treat them just exactly the same way that we've been doing. We'll do the same things, though. We're going to say 1 over x, give us some space to work, over, minus x over 64, and that's going to be equal to 0. I have 3 terms. I want you to note there are 3 terms in this equation. 1, 2, 3. The equal and the minus sign or a plus sign separates the terms in an equation, okay? What's the LCD? Well, the two denominators are x and 64. So the LCD has to have a combination of both of those. It has to include them both. It's going to be 64x. I'll multiply each term of my equation times 64x, even the 0, right? Because it's a term. Although it's maybe 0, but it's still a term. So I'll multiply it by 64x and then start clearing. These x's go away. I have 1 times 64. Don't forget the minus. These 64's go away. I have x times x. Over here, well, 0 times anything, right? All right, so what do I have? Well, let's get this so that x squared is all by itself. Negative x squared, I'll subtract 64 from both sides. Now, negative x squared. Now, I've got a negative is equal to negative. Why don't we just divide both of those by -1 so that they'll be positive? And now we're going to take the square root of both sides. Now, when we take the square root of x squared, it's x. When we take the square root of this, we've got to go, well, it could be plus or minus because we took the square root. Plus or minus the square root of 64 is an 8. So a positive 8 would work or a negative 8 would work if it doesn't cause an invalid condition when we plug it in. Let's look at it and see if these work. 1 over 8 minus 8 over 64 equals 0. Is that true? Can you convert 8 over 64 by dividing both of them by 8? Now this becomes 1, this becomes 8. 1/8 minus 1/8 equals 0. That one works. Let's do the negative. 1 over -8 minus -8 over 64. Well, this is a little confusing with the negatives, right? Let's change the negatives and put them out front. This is a negative 1/8. This is a positive, negative times a negative, 8 over 64, isn't it? Well, we do the same thing. We're going to reduce this. Negative 1/8 plus 1/8 is equal to 0. That one also works. None of them caused an invalid condition, but it's nice to know that we can check our solutions and prove that they do work. Now I've changed the next example for you. I know I'm thumbing through these real fast, but hopefully you figured out how to hit pause on your player, and you can pause this. You can pause it anytime you want to get more time. Example 6 I changed because I didn't like it, and I'm going to use this one instead. It is x squared plus 4 over x minus 2 is equal to 2 times x plus 2 over x. I'm going to do the same thing, so I'm going to give myself a little room and write it down like this. I'm going to say x squared plus 4, and that's over x, and give myself some space and say minus 2, and give myself some more space and say is equal to 2 times x plus 2 over x, and I'm looking for an LCD. Well, there's only two fractions, two denominators, both of them are x. LCD, therefore, is equal to x. I have to multiply x times each term in that equation. One term, two terms, three terms. Now, don't be confused. Just because there's addition here, it's still one fraction. Each fraction itself is a term, okay? So I'm going to say times x. Times x. No reason to write this one as a fraction. It's being multiplied times a whole number. And times x. And let's start reducing. Those x's go away, and these x's go away, so let's multiply out. I just end up with x squared plus 4, don't I? Minus 2x, and that's equal to, why don't we go ahead and distribute this multiplication? 2 times x and 2 times 2. Now it looks like I have an x squared, doesn't it? And so I'm probably going to want to get everything over on that side of the equation. So I'm going to say I'm going to subtract 2x over here, and also I'm going to subtract 4. That'll end up with 0, which is what I want. Get everything to go to the other side. I also have to subtract 2x and subtract 4. I'm lining them up with their like terms, so it makes it easy for me. Well, 4 minus 4 is 0. I do have x squared, however, and negative 2x minus 2x is a minus 4x. Okay, now I can factor. Can't I over here? I'm going to bring out the GCF of x, and what do I have left? X minus 4, and that's equal to 0. So what are my factors? What are my solutions? X is equal to 0, and x minus 4 is equal to 0, and that means x could equal a positive 4. I got to go check them out and see if they'll work. Is there going to be one of them might cause me problems? If I put in 0 for x, it's going to cause an invalid condition right here at the very beginning. So I'm going to automatically say that one won't work. Let's try putting in 4 for x. It says 4 squared plus 4 divided by 4 minus 2 is equal to 2 times 4 plus 2 over, what was it, 4. I think I wrote that one down correctly. Let me just double check it, make sure I've copied it right. Okay. Now solve, right? What is this? This is 16 plus 4, isn't it? Well, that would be 20 over 4 minus 2. And this is going to be equal to 2 times 4, which is 8. 2 times 4, which is 4. That would be equal to 12 over 4, right? You can do that in as many steps as you want to. Work it out yourself. 20 divided by 4 is 5. 12 divided by 4 is 3. 5 minus 2 is equal to 3. Our second solution did work and didn't cause an invalid condition, so we're good. Now, last two problems I want to look at are word problems, and they're really relationships of one number to another one, okay? This is how it works. It says they told us a camel can drink 15 gallons of water in 10 minutes. Well, that is what we call a ratio, a relationship of one number to another number. You do this all the time. You talk about miles per gallon of gas in your car, right? How many miles per 1 gallon of gas? So that's a relationship of two numbers to each other, and we always represent those as fractions. So we're going to say 15 gallons is to 10 minutes is the way we read it. And then we put an equal as, and we're going to have another relationship of two numbers to each other. The only thing that you have to be careful of is that the labels on the numbers match. In other words, if I had gallons in the numerator over here, I got to have it in the numerator here. I can't crisscross them. I can't put gallons here and gallons there. So I'm going to say 15 gallons is to 10 minutes as, and they don't know how many gallons. They're saying how much water, how many gallons can this camel drink in 5 minutes? I do know minutes. So I'm going to say that's going to be my x, my unknown. 15 gallons is to 10 minutes as x gallons is to 5 minutes. And you may remember doing this from previous math that you've had. What we do when we have a relationship of one number to another, one fraction equal to another fraction, is we cross multiply and then solve for x. So I'm going to say, it doesn't matter which one you multiply first, I'll say 15 times 5 is equal to 10 times x. Well, 15 times 5 is 75. The math's easy after that, especially since you got your calculator. So I got 7.5, but don't forget, 7.5 what? Well, x was gallons. 7.5 gallons of water. A camel can drink 7.5 gallons in 5 minutes because it could drink 15 gallons in 10 minutes. And that's how we would solve that problem, okay? Now let's take a look at the next one. This one tells us that there were 14.1 out of every 50 employees at a company were women. Well, I know the numbers. They wrote it a little strangely for me, but I'm going to go ahead and write the numbers down. I got 14.1 out of every 50. And I know that the 50 is employees, right? What's the 14.1? 14.1 out of every were women, right? These are women. 14.1 women for every 15 employees. And we've got another relationship they're going to ask us to compare it to. This says if there are 47,314 total employees. Well, I got to put that down here, right? Employees goes on the bottom. So I'll put 47,314. And they're asking me how many, estimate the number of women. That's my unknown again. Okay, so I multiply 14.1 times 47,314. And when I do that, I've already done the math here for you so you can see what it looks like. I end up with 667,127.4, and that's equal to 50x. Divide both sides by 50, and we see that it's 13,342.548 women. Now, usually when they say estimate, they're wanting us to go to a whole number here because we don't usually say, half of a woman doesn't work for us very well. So we're going to say we estimate that for every every 50 employees, sorry, we're going to estimate that there are 13,343 women, okay, in total in the company. That's what I'm trying to say. All right, hopefully that helps you with your homework. I'm going to sign off now so I can finish coughing and sneezing without doing it in your ears, and I will see you next week.